And eighth graders, it's Mrs. Johnson. We are going to do, I don't even know what page this is. Let's go the distance task. All right, I'm going to share my screen with you so that we can see what this first one looks like. When you're doing this task, it's really important that you actually pause it when I ask you to pause it. That way you can actually get the practice that you need. So if you see at the top here, here's what you need to know. The performances of the Podunk High School drill team are very popular during halftime shows. When they choreograph the dance moves to be performed on the field, they lay out their positions on a grid, and you can actually see that grid right here. Okay, so part A is saying, in one of the dances, they plan to make patterns holding long, wide ribbons. First of all, that sounds really awesome, but these ribbons are going to span from one girl in the middle to 6 other girls. And you can see on the grid, their pattern looks like this. So you've got girl in the middle, girl A, B, C, D, E, and F. So Gabriella, she is the G on the graph right in the middle there. She claims that the length of ribbon from herself to Brittany, who's point B, is the same as the ribbon from herself to Courtney. Is she correct? And how can you calculate the length of each ribbon needed? Let's ignore the fact that they could just line these up next to each other to see. We are going to calculate it mathematically because that is what we do. We don't think about the obvious things that are going wrong in this problem. Okay, so let's start. Let me get my pen on here. We'll start with blue. Yay, blue. Okay. And I'm going to slide this over here. Okay, Gabriella to Courtney. So this distance right here should be very simple to find. And I'm actually going to label that as, oh, hold on. I don't know why my pen is going crazy. But from G to C. How far is the distance from G to C? That is 1 space, 2 spaces, 3, 4, 5. How did I count that? Because it's a horizontal distance. I can just count the spaces. So from G to C is equal to 5. I don't know 5 what, but anyway, it's 5. Okay, but let's look at the other one. From G to B. Oh boy. I lost my 5. Okay, so from G to B, I need to find a couple other things. I want you to push pause and try to remember, how do we calculate that distance from G to B? What would be a way that we could do this? Push pause. Okay, one thing that I typically see students do, I always will see a student who draws a circle there and says, yeah, they're equal, because I could draw a circle and they all have the same radius. I'm not sure about your circle, but do you see how my circle, it's kind of hard to eyeball it to see if it actually is that way. So I don't think I would trust just saying that it's a circle. Another thing I sometimes see people say is they will draw this line here and say, yeah, this is an isosceles triangle. Again, prove it. How can we prove that it's an isosceles triangle? How can we prove any of this stuff? So we need more evidence than just it looks like it's the same length. Okay, so there's something that you learned back in the 8th grade. It sounds like the blank blankian blank blank. It is the Pythagorean theorem. If I draw in the 2 legs of this right triangle, I can use the Pythagorean theorem like this. From G to B, I can use the following method. A squared plus B squared equals C squared. Well, A, how far is A? 1, 2, 3 spaces. So I would say 3 squared. How far is B? 1, 2, 3, 4 spaces. So 3 squared plus 4 squared. And then how far is C? I don't know, which is why it's the unknown. I say it's just C squared. Okay, so 3 squared is 9 plus 16 equals C squared. What is 9 plus 16? 25, thank goodness, because I actually know that one. Because then to undo C squared, I need to take the square root of both sides. And I get 5 equals C. Dun, dun, dun. That distance is 5, which means that yes, Gabriella was correct. It was the same distance from Gabriella to Courtney as it was from Gabriella to Brittany. Well done, girls. Okay, so yes, Gabriella was correct. How do I know? Because I did the math. All right, let's try another problem. Clear all drawings. Okay. Part B, when they finish with the ribbons in the previous position, they're considering using them for a new setup as shown in the following grid. So the big difference is they put ribbons between the AB, the BC, blah, blah, blah. So the question is, will the ribbons used in the previous setup be long enough to reach from Brittany to Courtney? Will they be long enough to reach from Brittany to Ashley? Use some kind of mathematical reasoning to support your answer. So remember, last time they were 5 whatever's long. Try to figure out how long they need to be for both of these. Push pause, get these two solved. All right, I'm going to start. I'm assuming you push pause and you're ready to go again. From B to A, Brittany to Ashley. By the way, those are 2 of my siblings' names. Okay, so from Brittany to Ashley, I'm going to call that segment BA. I can count it. That is 1, 2, 3, 4, 5, 6 distances long. That is 6 spaces. So no, not long enough from the last setup because the last setup only had 5 distances long. So let's talk about from Brittany to Courtney. Well, for Brittany to Courtney, I can't just count that. I need to draw a right triangle around it. So here is my horizontal and my vertical distance. And these are 2, 4, and my unknown distance over here, which is C. So if I start with my Pythagorean theorem, a squared plus b squared equals c squared, and my a and b are 2 and 4, 2 squared plus 4 squared equals c squared. 4 plus 16 equals c squared. That is 20 equals c squared. I already know right now that this is going to be smaller than 5 because it's smaller than 25 right there. And when I take the square root of 20, I'm going to get a decimal approximation. Type that in my calculator. 20 square root is 4.47 approximately. So will the ribbon from the last one work? It's not perfect, but yes, it technically can span that gap. But I feel like they should probably just invest in new ribbons. I don't know. I'm not the drill coach or whatever this team is. All right, that was today's work. We're learning how to use that Pythagorean theorem on a grid. Yay! All right, let me clear this off and I should probably stop sharing this. See ya later.